Hello friends, welcome in this new video. In this video we will see some central differencing operator. Differencing operator is del f of x and it is defined as del f of x equal to f of x plus h by 2 minus f of x minus h by 2. This is the definition of the first central differencing operator del f of x. We write this as e raised to 1 by 2 f of x minus e raised to minus 1 by 2 f of x. So this is e raised to 1 by 2 minus e raised to minus 1 by 2 f of x, and using this del and the shift operator we get the relation e raised to minus 1 by 2. So this is a del. Now if we take e raised to minus 1 by 2 as a common factor, then del equal to e raised to minus 1 by 2 into e minus 1, and delta forward differencing operator delta equal to e minus 1. So this del equal to e raised to minus 1 by 2 into forward differencing operator delta, or delta into e raised to minus 1 by 2. Similarly, the nabla backward difference operator of f of x equal to f of x minus f of x minus h, or f of x minus e raised to minus 1 into f of x. We write this as 1 minus e raised to minus 1 into f of x. Again this del equal to e raised to 1 by 2 minus e raised to minus 1 by 2. If we take e raised to 1 by 2 as a common factor, 1 minus e raised to minus 1. So 1 minus e raised to minus 1, this is nabla equal to 1 minus e raised to minus 1. So we get nabla into e raised to 1 by 2. Hence we have this relation between these three operator, del equal to delta into e raised to 1 by 2 and nabla into e raised to minus 1 by 2 and nabla into plus 1 by 2. So this is about the central differencing operator. Now we define the mean operator, mean or average operator. Mu of mu equal to 1 by 2 into e raised to 1 by 2 plus e raised to minus 1 by 2. This is an average operator, average or mean operator, mean operator. So mu of yx equal to 1 by 2 into y of x plus 1 by 2 plus y of x minus 1 by 2. This is about the mean or average operator. Now mu square equal to 1 by 2, 1 by 2 here yx, 1 by 2 into 1 by 2 e raised to 1 by 2 plus e raised to minus 1 by 2 whole square operating on yx, or 1 by 4 into e raised to 1 by 2 plus e raised to minus 1 by 2 whole square operating on yx, 1 by 4 into expansion of this e plus 2 e raised to 1 by 2 e raised to minus 1 by 2 plus e raised to minus 1 operating on yx equal to 1 by 4 into e plus 2 plus e raised to minus 1 yx equal to 1 by 4 into e minus 2 plus e inverse plus 4. We write this as yx. So this is equal to 1 by 4 e raised to 1 by 2 square minus 2 into e raised to 1 by 2 e raised to minus 1 by 2 plus e raised to minus 1 by 2 whole square plus 4 into yx. What is this? This is expansion of 1 by 4 into expansion of e raised to 1 by 2 minus e raised to minus 1 by 2 plus 4 into yx. This is nothing but a delta. So we get 1 by 4 delta square plus 4 into yx, and hence we get mu square equal to 1 by 4 into delta square plus 4. So this is the relation between the mean operator or average operator and the first central differencing operators. Again, if we write the both definition of operator mu and del. What is a del? Del of yx equal to yx plus h by 2 minus 1 by 2 yx minus 1 by 2 by taking h equal to 1, and mu of yx equal to 1 by 2 into yx plus 1 by 2 plus y of x minus 1 by 2, or we write the same thing as 2 mu yx equal to yx plus 1 by 2 minus yx minus 1 by 2. Equation number 1, equation number 2. Let us add these two equations. That means 2 mu plus del operating on yx equal to this minus and this plus will get cancelled, and we get 2y x plus 1 by 2, or 2 into e raised to 1 by 2 into yx. So cancelling the yx, we get 2 into e raised to 1 by 2 equal to 2 mu plus del, or e raised to 1 by 2 equal to mu plus 1 by 2 del. Now this is the second relation between the operators which we get for displacement operator, then for central difference operator, and average mean operator. Now we define another operator, and that operator is called as a central sum operator. Central sum operator is inverse of first central operator, that is del inverse, and it is denoted by sum, sigma. So central sum operator sigma of f of x is defined as sigma of f of x plus h, x minus h plus f of x minus h by 2. This is the definition of sigma, and it is a, what is this? This is a central sum operator, central sum operator. Now from this we deduce that here sigma f of x minus sigma f of x minus h equal to f of x, we write this as e raised to minus 1 by 2 into f of x, sigma f of x minus sigma into e inverse into f of x equal to e raised to minus 1 by 2 f of x. So here this let us consider, we write this as a sigma into sigma common 1 minus e inverse and f of x common equal to e raised to minus 1 by 2 into f of x. So from this we get an operator relation sigma 1 minus e raised to minus 1 equal to e raised to minus 1 by 2, or sigma equal to e raised to minus 1 by 2 divided by 1 minus e raised to minus 1. So this gives us sigma raised to 1 by 2 divided by e minus 1, and this is the relation between the shift operator and the operator central sum operator sigma. So I hope friend you got the idea of the central sum of operators. Thank you friend, thank you for watching the video.